Assalamualaikum and hi there. We are from Group 6. We are going to present Flight and Mission Computer. So before that, I will introduce myself. My name is Muhammad Iman bin Ahmad, matrix number 205901. I will be explaining the introduction of Flight and Mission Computer. So before that, we need to know what is Flight and Mission Computer. What is Flight and Mission Computer? Flight and Mission Computer are the electronic devices used in aircraft, artificial satellite, and even spacecraft. So this flight and mission computer are included with communication, navigation, monitoring, flight control and management system. I will go deeper into this four later. So flight and mission computer are designed and feature core processing capabilities that can host multiple mission, flight management, and display management processing function. So why communication are included in the flight and mission computer? We need to know that communication is very important. It is the key factor that need to be utilized in the system. Why? Because without communication, we just don't know what to do in the air. So the pilot just fly and imagine it if we are in a war and we don't have communication, so we don't know who is the enemy. So we need to contact the ground crew. So the communication is very important. It became the backbone for safe flight. Okay, the second one is navigation. So why navigation are included in flight and mission computer? Because flight and mission computer generate and include advanced navigation system. So I give example here, TACAN, Tactical Air Navigation System. So TACAN is the most common use navigation system in military. It have more precise navigation system version from the previous like VOR or DME. So Takan are used for generating routes in the sky. So because there's no signboard in the sky, so this system provide the navigation for the pilot. So let's go to monitoring. Monitoring is also very important in flight and mission computer because the display of information, because monitoring also affect performance of a flight. So back then we are using gauge and analog display because of the development of monitoring in aircraft and development of flight and mission computer. Now we have HMD and HUD, helmet mounted display and heads up display. So now the pilot can focus on the outside world because of the display of information now in their field of view. So then they can concentrate on the flight. Now let's get into flight control and management system. In this new age, the design and the manufacturing of the aircraft will be advanced. I can say that in order to handle the aircraft, it will be harder. So this is where flight and mission computer system plays significant role in order to help controlling and maneuvering the aircraft. We have this advanced automatic system where the flight movement are converted into electronic signal. It helps to control movement of the aircraft. It helped to be the flight to be more efficient, and it's also reduced the pilot workload. For more deeper information and with how we need to know the flight and mission computer system works, so my friend will be explaining to you. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning to Dr. Amzari and Dr. Zairil and our fellow friends. My name is Amirudin bin Azlan. My matrix number is 208062. I'm from Group 6. We explain about history of flight and mission computer. So for this part, I will explain about the first flight and mission computer, which is E6B. The E6B was developed in the United States by Naval Lieutenant Philip Dalton in the late 1930s. A little background information about this inventor is that Philip Dalton was a Cornell University graduate who joined the United States Army, and he was an artillery officer, which in time was promoted to become a naval reserve pilot. Philip Dalton and TVH Wims, who worked together and started to invent, patent, and market a series of flight computers. However, he died in a tragic plane crash with his students. Dalton's first popular computer was his 1933 Model B, the circular slide rule with true airspeed (TS) and altitude correction pilot. A few years later, Mark 7 has been invented by Dalton again, following his first Model B as a focal point. At this moment, Dalton was a little bit unsure about his design, so he decided to plan and create something more accurate, easier to access, and durability in higher flight speed. Next, in 1936, Dalton included a double drift diagram on its reverse, which created the E1, E1A, and E1B. Moving along, in 1938, he made a few changes. Wims used to call the flight computer as Model J, but then both of them agreed to introduce the invention as E6B, and the Army Air Force placed a large amount of order, which is over than 400,000 units of E6B. After that, the design was so special because most of the plastic used in this flight computer may glow under the black light. So here are some first stories. Here are some history about our first flight mission and computer. Thank you.
Hello, Assalamualaikum and good evening. My name is Ahmad bin Ahmad Jasrul. My message number is 207449 and I will be covering the methodology part. So let's move on to the next slide. So more electric aircraft, that is the methodology of our report. And the data study obtained is trade-off to be performed and is driven by subsistence specification definition, and the analysis is the aircraft subsystems. What we will be comparing about in this methodology is electrohydrostatic actuator, which is EHA, and electromechanical actuator, which is EMA. Next slide is, there will be three parts in this analysis in the methodology. The first part is electric flight control actuation system architecture. EMA is lighter than EHA and seem to have more energy efficient. Second, in flight control surface actuation, critical hazard for the EMA may be affected. EHA will then has the major advantage. Third, EMA may be fit for the activation of flight and ground spoilers. Moving on to the next point, vehicle levels analysis. Maximum pump pressure and pump displacement were observed for EHA, while the BS and GB gearing ratio are used for the EMA. Both EHA and EMA maximum limits were enforced for permissible current under stall load and motors RPM. Configuration 2 EMA means in weight advantage of about 6% over configuration 1 EHA. Mission level analysis, that is the last part in the methodology, last point, So primary control surface movements rely on the phase of flight and through the mission simulation. Next, the high lift devices were assumed to deploy and or retract in a manner consistent with what is observed. Lastly, mission fuel burn may be varied due to a difference between the two configurations. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan Al Faizeen bin Yazi. My matrix number is 206481. So today I will be presenting the discussion of flight mission computer. So this flight mission computer is designed to handle mission processing, sensor processing, and display processing. While on military aircraft, they can use the data from the sensors to create a clear picture of the battlefield and control the weapon and combat systems. So It is proven that this mission computer can reduce the pilot's workload through full automation and through fine control adjustments such as autopilot. Okay, so they can literally fly the airplane itself because they have authority over major control surfaces and throttles. So that's mean any malfunctions could turn the situation into a very dangerous situation. There were some accidents reported because of a badly written computer software. For example, Boeing 737 MAX that has been grounded in March 2019 because of 2 crashes and 346 people killed during the crash. So the crash happened just after the takeoff when the stick shaker on the captain's side began to vibrate. So as we know, the stick shaker is designed to warn the pilot of any impending stall that can cause dangerous loss of control. So the captain was confused because the plane was flying normally and nowhere near a stall. So then after 30 seconds, he noticed that there is an alert on this flight display. So then, which means the mission computer detected a malfunction sensors. So after troubleshooting, he realized that the sensors from the left side of the plane begin to getting bad data. So he switched the primary display to use the working sensor from the right side only. So this process took under a minute, and then everything goes back to normal. However, the other problem occurred, and the planes starting to lurch down and crash. So this similar problem happened to the other crash also. So it is very important for manufacturers to choose hardware that is proven to be safe rather than run a fleet of airplanes with some cutting edge tech which has bugs that yet to be worked out. So a simple mistake we make could harm life of 100 people. So that's all for me. Thank you.
In conclusion, we can summarize the flight mission computer and say that it's a computer that processes the aircraft's data, including voice, video, graph, and so many things. The flight mission computer is very important for an aircraft to analyze and manage missions. Flight mission computer can be the best choice because it's faster, the most safety, has less consuming of power, has less size and weight, less cost, and with all of that, it has very high accuracy. In addition, the flight mission computer is not just for civil aircraft. It has a big part of importance in military aircraft because it creates a picture of battlefield and control combat and weapon systems. Flight mission computer importance is in everything in the aircraft, such as communication, control management, navigation, and monitoring, and so many things. Thank you.